We call a Markov chain an absorbing chain if one or more than one states are absorbing states and the rest are transient. For example, in this graphical representation of a Markov chain with 8 states, you see that state 1 and 7 are absorbing states, because once you're in 1 and 7, you do not transition to any other states, and you stay in the same state with the probability of 1. However, if you're in 2, 3, 4, 5, 6, or 8, there is a chance, or eventually, you will transition to one of these two absorbing states, and once you do that, once you're in 1 or 5, 1 or 7, there is no way you can go back to any of those states. Therefore, we would say they are transient states. For example, if you're in 4, if you're here, there is a way that you leave 4 and never be able to come back to 4. For example, you can go to 5 first, then go to 6, then go to 7. Once you're 7, you will not be able to go back to 4. Let's look at some examples. Example 1, accounts receivable. A firm assumes that an account is uncollectible, which is written off as bad debt, if the account is more than 3 months overdue. So we define 6 states for each account in this firm. State 1 is new account, it's in the first month. State 2, payment on account is 1 month overdue. So our time steps are in month. This is a discrete time, a stochastic process. Markov chains are the ones that we are studying are discrete time. So the time here is in month. The state 2, it's 1 month overdue. State 3, 2 months overdue, and state 4, 3 months overdue. So if they don't pay it off the next month, it's going to be categorized as bad debt, which is not collectible. So I have 6 states. I can create a transition probability matrix for it. Here you see that the columns and the rows are the states that we just defined, and from the past data we see the probabilities. For example, if out of all the new accounts, 60% of them become overdue next month, and 40% of them have paid off their debt in the same month or the next month. And note that probability of going from new account to 2 months in debt is 0, because transition probability matrix is only about the probability of going from one state to next in one step, and one step here means 1 month. You can't be 2 months overdue if you just opened the account. Next month you cannot be 2 months overdue. 2 months is 2 steps from now. However, if right now an account is 1 month overdue, based on past data, 50% of them pay off their debt, and 50% of them don't and become 2 months overdue next month. And that's the rationale behind these probabilities and how we obtain them. But now that we have this transition probability matrix, I can create a graphical representation for it. 4, 5. So this is the state 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. Okay. Let me change this 6 to 5 and this is to 6. So 1 month new account, next month it will either be paid off or becomes 2 months overdue. 1 month overdue. 1 month overdue, state 2. Next month either will be paid off or becomes 2 months overdue. 2 months overdue, next month either paid off or becomes 3 months overdue. If it's a 3 month overdue account, next month they will either paid off or they will become a bad debt. So if they are a bad debt, they remain as such forever. We close that account basically. Or if they are paid off, then they are just paid off. That account is closed. Therefore, 5 and 6 are absorbing states, and because all the rest are transient, which means you cannot be 1, 2, 3, 1 month overdue, 2 months overdue, 3 months overdue, or a new account. You will eventually transition to closed account, either paid off or written as bad debt. So those are all transient. So this does classify. We can classify this account, this system, as an absorbing chain, because it has 2 absorbing states and the rest of the states are transient. Okay, now we're interested in answering this question. What is the probability that a new account will eventually be collected? How do we know, or we're interested in knowing that? What's the probability that a new account will eventually be collected? We know that there are many ways for a new account to be collected. For example, they can be paid off next month, or they can become a 2-month overdue and then they paid off. They can become 3-month overdue and then get paid off. So there are different ways. How do we get the overall probability of that? So that's one type of question that we are interested in for absorbing chains. We want to see what's the probability that one of the transient states ends up in one of the specific absorbing states. Another example. A firm employs 3 types of lawyers: junior, senior, and partner. Promotions in the next year are also possible. So if someone's a junior now, so the states of employees, the system here is an employee. The state of the employee could be junior, senior, partner, or they can be classified as someone who left as a non-partner or someone who became a partner. So 5 states. And if someone from the past data, again, we have realized that juniors, 80% of them remain junior, 15% of them become senior, and 5% of them just leave the company as non-partner. If someone's a senior this year, there is no way that they become a junior, so that's probability 0. 70% of them remain senior next year, 20% of them become a partner of the company, and 10% of them just leave the company as non-partner. And if someone already is a partner, they can either remain as a partner, which is the case for 95% of them, or they can leave the company as a partner. So if they leave the company, they will be classified as left as a partner. So that's 5%. And the thing is here, if someone leaves the company, it basically they will be always in that state. They left, either as non-partner or partner. So I have 4 states here: 1, 2, 3, 5 states, 4 and 5. Junior can remain a junior or become a senior next year, or this is all about next year. Here the time period is 1 year. Again, discrete time, a stochastic process. And they can also leave as non-partner. A senior can remain a senior next year, they can become a partner next year, or they can leave as a non-partner next year because they haven't become a partner yet. If someone is a partner, they can leave as a partner, or they can just stay as a partner. And once you leave, the probability that you go back to any of the other states is 0, and you will forever, with probability of 100%, you will remain in the same state, which is left. either as a non-partner or partner. So these two are basically absorbing states. The rest are transient states, which means you will not stay there forever. You eventually leave the company. And because of that, we can classify this Markov chain as an absorbing chain. Now we're interested in answering questions such as, what is the probability that a newly hired junior, someone who is in a state 1, will leave the firm before becoming a partner? So basically it's asking, what's the probability that the junior eventually leaves as a non-partner? What's the probability that this state 1, ends up in absorbing a state 4? Second question, which is a little different from the questions we've seen so far for this example and previous example. This question so far are the probability that a transient state ends up in one of the absorbing states. But here the question asks, on the average, how long, it's not a probability, or how many steps, how many years, how long does a newly hired junior lawyer stays with the firm? It basically asks you, on the average, how long does it take for them, for a state, a transient state, before they get absorbed in one of the absorbing states. So before a junior either leaves as a non-partner or leaves as a partner, for how long on average they stay with the company. So this is another type of question that we are interested in. And to answer this type of questions, we need to reformat the transition probability matrix and then do some calculations to find those probabilities or average expected number of steps before a transient state leaves or gets absorbed in one of the absorbing states. So how do we reformat these transition probability matrices? So as you notice, in absorbing chains we have two types of states: transient, absorbing. So the first rows, we want the first rows to be transient and the last rows to be absorbing, which was the case here. You see that first rows, junior, senior, partner, were all transient, and the last two rows, leave as partner, leave as non-partner, those were absorbing. Or in the previous example, new account, 1 month overdue, 2 months overdue, 3 months overdue, they were all transient. They were in the first rows, and then paid and bad debt, which were absorbing, they were the last rows. So that's the first thing we want to do. And once we do that, we call these, so if you have S, S transient states and M absorbing states, if you have S total number of states and M absorbing states, S minus M rows is going to be the top rows, and then M rows, which are the absorbing states, will be at the bottom and at the right. This is so I'm going to draw a line between basically absorbing states and transient states. I'm going to draw a line. So that's my new matrix now. Here you notice that I'll have the identity matrix here, and there will be all 0 here. You see that identity here, zeros here, 0, identity. And then we call this matrix here Q. We call this one Q, and then we call this one R. Alright. We call transient states Ti, and we call absorbing states Aj. For example, T2 in the second example is being a senior employee, which is a transient state. Or A2 is leave as partner, which is one of the absorbing states. Alright. So Q will be a 4x4 matrix, which is S minus M. S was 6, total number of states. M was 2 absorbing states. 6 minus 2, 4. So it's a 4x4 matrix. And then R is an S minus M by M matrix, which is 4 by 2. This represents first absorbing states, this represents second absorbing states. And these rows represent the transient states. Okay, so far we just reformatted the transition probability matrix, and we extracted two matrices from it. One of them was Q, one of them was R, after drawing those lines between the states. Okay, once we have these, we can answer these questions. Two important questions for absorbing chains. One, if the chain begins in a given transient state, for example, if an employee begins as a junior, or if an account is right now, is this month, is 2 months overdue, right? These are all transient. If a chain begins in a given transient state, and before we reach an absorbing state, before that employee, that junior employee leaves the company, either as a partner or non-partner, or before that 2 month overdue account is paid off or written as bad debt, what is the expected number of times that each state will be entered? So this is about the number, it's not a probability. What is the expected number of times? To answer that question, we need to get the inverse of this I minus Q matrix. I is the identity matrix, and that minus Q, which was here, you saw that it was the northwest part of the reformatted matrix. Q, I minus Q, then you get the inverse. Once you get the inverse, that is ijth element of the matrix, row I, column J of this new matrix, this inverse that we calculated. So if we are at present in transit state Ti, for example T2, which was 2 months overdue for the first example, the expected number of periods that will be spent in transit state Tj, for example 3 months overdue, or T1 in the second example was junior, T3 was partner. Before absorption is ijth element of the matrix. For example, if someone's a junior now, for how many years there will be a partner before they leave the company? So just note that the first type of question is asking about the number of times you enter another transient states before you get absorbed. Second type of question, if a chain begins in a given transient state, for example, an employee is right now a senior, or if an account is 3 months overdue, if it begins in a given transient state, what's the probability that we end up in each absorbing state? For example, if an employee is a junior now, what's the probability that they leave as a partner? What's the probability that they leave as non-partner? If an account is 2 months overdue right now, a specific account, what's the probability that they are written as bad debt? What's the probability that they will be paid off? So transient to absorbing. Second type of question is asking about transient to absorbing. First type of question asks about transient to transient. So to answer that question, we need to calculate I minus Q inverse again and multiply it by R. What was R? R was the northeast part of the reformatted matrix. Now let's look at some examples. Let's answer the question that we had for those two examples with this new knowledge that we have. So it asks, first question asks, what is the probability that a new account is T1. T1 will eventually be collected or paid off. That was A1, absorbing state 1. What is the probability? So for that, it's asking about probability and it's asking about a transient going to an absorbing state. And for that, we would calculate I minus Q inverse times R, and then we would look at first row IJ, right? First row, first column. Second question, what is the probability? Again, probably second type of question. That a 1 month overdue account, was transient state number 2 in the first example. It will eventually become a bad debt. This was A2. So again, this is the second type of question. I minus Q inverse times R, and then I look at the second row, second column to get that. Third question, if the firm's sales average, we'll get that question later on, but first let's answer the first two questions. First, let's calculate I minus Q. What was Q for the first example? Q was this part. So I minus that basically means find the identity matrix of size 4 by 4, which is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. That minus Q. If you do that, you're going to get that minus, so I minus Q is going to be here. You see that I minus Q is going to be that, which is, if you do the calculation, you will get this new matrix, I minus Q on the left. And if we get the inverse of that, and then multiply it by R, we get this final matrix. And the answer to the first question is here. First row, first column of I minus Q inverse times R. So what I did to get that matrix, I basically got the inverse of I minus Q, which was this one, and then I multiplied that by this R matrix that I had here, and I got this new matrix. As you see, the elements here are probabilities between 0 and 1. Sum of each column, sum of each row is also 1. Because if you're in a transient state, you're going to eventually end up in one of the absorbing states, either the first one or the second one. So sum of the probabilities should be 1. Exhaustive and mutually exclusive. Alright, so there is a 0.964 probability that if that a new account will be eventually collected, which is good. And 0.036 is the probability that a new account will not be eventually collected. It will be eventually marked as written off as bad debt. Alright, how about the second question? What's the probability that a 1 month overdue, which is second transient state, a T2, will eventually become a bad debt? What's the probability that T2 ends up in A2, which is here? Very small probability, 6%. How about the last question? If the firm's sales average 100,000 per month, which means $100,000 are given to new accounts, how much money per year will go uncollected? We just calculate the probability that new accounts will go uncollected. That probability is here, 0.036, and we multiply that by the total amount that the loan or whatever that's given to the customer, to the clients. So I write 100,000 times 12, because I'm only get it for per year. I calculate it per year. 100,000 times 12, and that times probability that they go uncollected, or a fraction of them that go uncollected, 36, and I will get 12 times 36 times 100, whatever that number is in dollars. That amount is the amount that cannot be collected. 43,200 will be uncollected per year. Alright, how about the second example? So second example asks what is the probability that a newly hired junior transient state 1 will leave the firm before becoming a partner. So here it's asking about going to the absorbing chain. Basically, what's the probability that they leave the company as non-partner? That was a state, leave as non-partner. That was a first transient state, basically. So that's A1. So to get that, again, I minus Q inverse times R, and we want the first row, first column. Second question, on the average, how long, it's not a probability, how long, first type of question, does a newly hired junior lawyer stays with the firm? Basically, we just calculate I minus Q inverse, and in that matrix you will see that matrix goes from T1, T2, T3, junior senior partner, T1, T2, T3, junior senior partner. So you basically get some of these numbers. If they're right now a junior, this number here tells you expected number of years that they stay as a junior, expected number of years that they will be a senior, and expected number of years that they will stay as a partner. So some of those is the answer to this question. How long does a newly hired junior stays with the firm? So it's some of those three. Next question, what is the average length of time that a partner spends with the firm? Similar to the previous question, except this time I'm looking at the third transient state, which is the partner. So there is no way that a partner transitions to a junior, so that's not possible. There is no way that a partner transitions back to senior. So basically this asks you how many years, how many periods they will remain as partners. So I need to look at that number, and I expect those two numbers to be just zeros. If someone enters as a senior, which is T2, for how long on average they will remain a partner before they leave the company, either as a partner or non-partner? Again, I look at I minus Q. It's not asking about probability, it's asking about number of periods, expected number of periods before entering an absorbing state, which is leaving the company as a partner or non-partner. It's asking about T2 going to T3, so I just look at this value here, and this was the answer to this question, and this was for second question. What percentage of seniors leave the company as non-partner? So I'm looking at T2 going to A2. So for that I need to calculate I minus Q inverse times R, and then second row, second column. So in that I'll have T1, T2, T3, A1, A2. second row, second column, T2 to A2, and that's the answer to here. Now let's see what the calculations are and what the actual answers are. So here are the calculations. First, I calculate I minus Q. I is the identity matrix minus Q that I have here in the original matrix, 0.8, 0.15, and so forth. From there, I get I minus Q, and then I calculate the inverse of that. We learned how to calculate an inverse of a matrix, which is very easy for absorbing chains because we have a lot of zero elements here. You will see that in the calculations. They are very easy, or you can use the online tools that are available, such as Wolfram Alpha, the website. Alright, once I get the inverse of I minus Q, which are these numbers in red, I'll be able to answer these questions, the second and third, which are asking about how long does a newly hired junior lawyer stays with the firm. Basically, sum of 5, 2.5, and 10. Basically, 17.5 years they all stay with the firm, juniors, on average, based on this transition probability matrix that we have. Third question, what is the average length of time a partner, someone who is in transition state 3, will spend with the firm or remain as a... Remember we said we expect those two numbers to be 0. Partner 2, senior and junior, will be 0, which is the case after we calculate I minus Q inverse. And then 20 years is how long they are expected to stay with the firm. The other questions, which are probabilities, we had another question too. If someone enters as a senior, T2, what's the probability that they for how many years they remain as partner? For that, we calculate T2 to T3, which is 13.3 years. Note that I minus Q is not a probability matrix. It's a number of steps, number of periods, number of years, month, and so forth. And the other questions, first one and last one, are asking about probabilities. What's the probability that a newly hired junior will leave the firm before becoming a partner? T1 to A1, which is 0.5. 50% of juniors leave as a partner, and 50% of them leave the company before they become a partner. But eventually everyone, junior, senior, and partner, eventually all of them will leave the company. For the last question, what percentage of seniors, T2, will leave the company as non-partner, which is very small point, which is smaller than the previous case. If they move higher to senior, it's less likely that they leave as a non-partner, which is 0.33. Okay, so that's everything about absorbing chains. All you have to do is to reformat the original transition probability matrix so that the transition states are at the bottom and to the right of the matrix. Then you divide the matrix, you find Q and R. Then you calculate I minus Q inverse to answer questions that ask about if you're currently in a transient state, for how many periods you will remain in another transient state or the same transient state before you get absorbed. And if it asks you about probabilities, if you're in a given transient state, with what probability you end up in this specific another absorbing state, then you use I minus Q inverse times R. Yep, that's everything about absorbing chains.